I was so puzzled when seeing the news from Ubiquiti about the WAN switch. I couldn't wait on the release date. I ordered one. Then 2 days later, it's on my desk. It's a pretty small box. It comes with regular rack mount accessories. To my surprise, it has two power supplies. There are totally 4 ports, one in the back for management and three 10 gigabit ones in the front. Even though the dimensions are the same as USW aggregation, it seems it's much heavier. I really want to know what's inside, so I decide to open it up. You can see more than half of the internal space is occupied by the two power supplies. And I don't want to tear it down furtherly to see the chips, so yeah, that's it. My complaint about the hardware design is the device is too shallow. If Ubiquiti can move the left side power supply to the back to make it deeper, then make the device half the width so you can have two WAN switches just by occupying one row of your rack, that will be much better, because many people may need multiple such WAN switches because they have multiple ISPs. Now let's see what type of information we can get from the UniFi network controller from this WAN switch. From the overview page, the simple 4 ports with the speed, and then if you go to port manager, for each part, basically you have nothing to set. Of course, here you can see the two power supply units information, whether they are online or not. Then if you go to insights, so basically the insights don't provide any insights. It's basically useless. And I don't think for this switch you care about the CPU and the memory. Then if you go to setting, basically the setting is just about how you manage this switch to enable SNMP, how to get IP address, how to set the boring LED, nothing else. So if you have a question about why this switch doesn't have the traditional left side LCD monitor, instead it only has a LED, I believe this very simple management user interface answers the question. It's simply because there's nothing to display if it really has a LCD monitor. First, let's see the WAN switch works in action. This is my lab environment. I have two EFG. I already configured the shadow mode and automatic takeover. In the UniFi network controller, you can see all the switches access points. They are in green color. If I go to settings, control plane, for console, you can see I have a shadow gateway, which is ready to take over. Then in the lower part, let me SSH to the EFG. I know the one port used for the primary EFG is the port 5, so internally it's Ethernet 4. Let me see the Ethernet 4 port's IP address. It's .2.155 because I run this lab environment behind my gateway. That's why even for the one IP address, it's still private, but it doesn't matter. Then I want to see its MAC address. I run the IP link command, show the same port, Ethernet 4. Okay, this is the MAC address. The reason I want to show this is, first I want to see after the failover, what's the IP address I will get for the shadow EFG. Second, I want to see its MAC address for one part. So I will leave this screen here. The upper one is the primary EFG. The middle one is the WAN switch. For the two EFG, port 5 is connected to the corresponding ports in the WAN switch. And the ISP part of the WAN switch is connected to the internet. And you can also see for both EFG, the port 6 is used as LAN port to connect to switch. Okay, and this red one is crucial. It's connected both the port 2 of the two EFG. It's used to synchronize configurations. Now let me trigger a failover by shutting down the primary EFG. Okay, shut it down. Primary EFG shutdown started. Then let me switch on the screen for the shadow EFG. You can see it is still in shadow mode, but it's about to take over. Okay, primary gateway is done. From the UniFi network controller, you can also see the status is changed. In fact, it cannot connect to the EF3 already. Now, network controller is refreshed. The taking over is already started internally. Okay, it's in the process of failing over. In fact, the whole process was pretty long, but I already cut the static part just to reduce the video time. Okay, the failover has completed. You can see now the shadow gateway already taken over. Now it is the primary gateway. Then let me connect to the current effective EFG using SSH again. Then run the same command, show the port file's IP address. Interestingly, the exact same IP address. Now let me check its MAC address for the same port file. The reason that DHCP server gives it the exact same IP address because it has the exact same MAC address. So the internal failover mechanisms guarantee the shadow mode EFG when it takes over, it has the same MAC address for the one part so that it will get the same IP address. This behavior is not due to the WAN switch. It's the functionality of the gateway. Okay, we just experienced how the WAN switch is supposed to be used. In order to understand more about the behaviors of this WAN switch, I decided to connect 3 computers to this WAN switch. Of course, this is not the real usage for this switch, right? But I just want to use 3 more general computers to flexibly test the network behaviors. For the first 2 parts, for the WAN switch, I connect them to 2 Linux machines. And then for this ISP part, again, just like a normal usage, I connect to the outside world. In my case, connect to a switch in my home network. And then I have a 3rd computer. It is also inside my home network. Of course, the computer 3 is not directly connected to this ISP part because I need a way to make DHCP works, right? So I have to connect the ISP part to my home network. Okay, this is the connection. Let me show you their IP addresses for the 3 computers. As you can see, their subnets are the same, .2, .something. The reason is they are all getting their IP addresses from my home gateway. So that makes sense because this is a L2 switch. They are all in my default network. In my setting, the subnet is .2, .something. Okay, but you can see all 3 of them, they have different IP addresses. Remember in my previous shadow mode testing, these 2 parts got the same IP addresses, right? That's not due to the switch. That's due to the fact that they have the same MAC addresses. But this time, because computer 1 and computer 2, they have different MAC addresses, that's why they got different IP addresses. Okay, let me first test from computer 1 to computer 3. Okay, it's pingable. And from computer 2 to computer 3, also pingable. If this WAN switch works like a router, internally it may have a firewall so that from the WAN part, if you will, you cannot directly connect to the local client, right? But because this is just a switch, this is not a router, so from the computer 3, I can successfully reach out to the computer 1 and computer 2 without any problem. So now we confirm these 2 links works as expected because this is a switch, right? Then what about computer 1 and computer 2? If this is really a switch without special setting, computer 1 and computer 2 should be able to talk to each other, right? Let me try from computer 1. Nope, that's strange, right? So that means something's happening inside this switch. The switch prevents computer 1 from talking to computer 2 on purpose. And one thing I don't want to waste your time is about the management part. Because this management part is to manage this switch, it has totally different IP address in different subnet. There's no router here. Of course, these 3 computers, they cannot directly talk to this switch. Okay, that's isolated for sure. I am still not convinced that this WAN switch is simply a dumb switch plus a management part so that you can see some simple statistics. So I decide to SSH into the switch. In the left side SSH session, go to the switch. Let me first see from the Linux operating system level what interfaces I have. Only two interfaces have IP addresses. This one, Ethernet 0, with this IP address, it is for management. So this part, Ethernet 0, is the one in the back of the switch, not one of the three 10 gigabit. That makes sense. Then if I try to see the bridge information, there's no bridge defined. If I try to see routing information, there's only one simple rule. It's about this management part. So whatever I can see from the Linux operating system level is only about the management part, which makes sense because this Linux operating system should only have control to the management part. For these three 10 gigabit parts, they should be controlled by separate hardware, not by the Linux operating system. To show the three 10 gigabit parts information, let me go to CLI. Yeah, this switch behaves the same as the current generation of UniFi switches. Instead of using Telnet, you directly run CLI. Go to privileged mode. I am interested in the switch part information for the three parts. To show that, let me run this command, show interfaces, switch part. There are three 10 gigabit part. Let me see the first one. Okay, this returns very interesting, very important information. See, the part mode is tunnel. If you are familiar with UniFi switch part setting, you may know you can set it to access part, trunk part. But this particular switch, the part is set to interesting part mode, which is tunnel. It doesn't say what type of tunnel. I guess it's 802.1q, which is about VLAN. Let me confirm that. Before that, let me show the other two 10 gigabit part. Okay, the same information. Okay, the same information. Now let's look into this tunnel thing. Because here it doesn't tell me what type of tunnel. Let me go to config mode. Go to the first 10 gigabit part. Now I'm in this particular port's config mode. Then let me run switch part command. From the command help, you can see what tunnel is. Yes, my guess is correct. It's 802.1q tunnel part. Now it makes sense because normally you set the tunnel mode for a switch part on a edge switch from the service provider's bridge. On the screen, let me show this Wikipedia article about 802.18d. So basically, it's a addition to the VLAN standard. It allows inner VLAN tag and outer VLAN tag, so-called Q-in-Q. In this way, the service provider can achieve the effect that just by using its own VLAN, one VLAN, it can serve multiple customers which may have different VLAN IDs. So that's the purpose of this Q-in-Q tunnel. And it makes sense. Ubiquiti sets the ports to tunnel mode for this particular switch. In the right side, let me SSH to a regular switch which you use in LAN part. This is a USW Pro Max 24 switch. So let me go to CLI, go to EN, then run the same command, show interfaces, switch part, 10 gigabit Ethernet part 1. See, this is the difference. Here the part mode is hybrid. Then it specifies what's the native VLAN, what's the tagged VLAN. Basically, this part is a trunk part. So that's the regular setting on a LAN switch. If you compare the left side WAN switch, the port mode is set to tunnel. Interesting? I believe at this moment, many of you are just like me, still confused about what's the point of this WAN switch. According to Ubiquiti, this switch can link two shadow mode HA UniFi gateways to a single ISP. Let's talk about it. Before this WAN switch, how you can achieve the same or similar effect. If you're lucky, your ISP either provides you two separate links or the modem from the ISP has multiple Ethernet ports. Then you don't really need this one switch. You can simply use the two links provided by your ISP. You are good to set up shadow mode. But if your ISP only provides one link, no problem. You can buy a very cheap layer 2 dumb switch. On Amazon, there are a lot of $10 switches with multiple ports. That's good enough if you are okay with 1 gigabit speed. Of course, this UniFi switch has 3 10 gigabit ports. If you want to buy multiple 10 gigabit ports unmanaged switch, that won't be very cheap. And then you will also lose the so-called management functionality provided by the UniFi WAN switch. So someone may ask, why you want to use dumb switch? Why not use a managed switch? Then you can manage it, right? You know what? For a WAN switch, a dumb switch is better than smart switch. Reason is it is outside of your firewall. It is directly connected to internet. The smarter your switch, the higher chance it will be hacked or it will be abused so that you may have some security issue. A dumb switch is perfect for this scenario. This disadvantage for smart switch doesn't apply to the UniFi WAN switch. The reason is the management part is separated with the 3 10 gigabit parts. There's another option. Yes, normally your switches are in the LAN part or the ports are for LAN. But the special part for this type of setting is you create a special VLAN. In the old UI, it's called VLAN only network. In the new UI is called third-party gateway, but no matter what, you create a new VLAN of that type. Then for the switch ports, you assign the new VLAN as the untagged VLAN. Then you connect your WAN ports and the ISP link to those newly assigned switch ports. So in that way, your traffic won't be routed by your gateway and your gateway won't try to assign IP address to your WAN. But I personally don't like this approach. The reason is if you plug your device to the wrong switch port, you may mess up your WAN security. And if you accidentally reset the switch all of a sudden, all your ports, including the intended WAN ports and the ISP port, will be in default network. Your traffic will be exposed to internet. It's very dangerous. Of course, I understand why some people like this approach because you can achieve both benefits, WAN switch and the LAN switch, by using the same UniFi switch within your LAN and it's managed. Okay, in summary, I don't think this UniFi WAN switch is really absolutely necessary for shadow mode, high availability purpose to share the internet connection from one ISP, but it's an elegant solution. Yes, it will cost more, but whether it worth the money or not, only you, the potential buyer, knows the answer. Okay, thanks for watching.